Hey, everybody, welcome to another episode of Behind the Cape. I'm Data Superhero Keith Belanger, and today I'm joined by fellow Data Superheroes Saurabh Kumar. Today we're going to be talking about Snowflake Polaris Open Catalog and Apache Iceberg tables. I know I'm very excited. Welcome to the show, Saurabh. Great to have you.
Thanks, Keith, for having me on the show.
Yeah,
Um,
why don't you tell everybody a little bit about yourself?
sure. Before I introduce myself, I want to say something.
Sure.
Ever since I have been part of the Data Superhero program, I have been following Behind the Cape series, and it was there in my wish list to be on your show. So I'm very glad to be part of
Well,
this forum today.
well, thank you. I'm very excited to have you, and I think everybody's going to really be excited for whatever you have in store for us today. I know personally, I'm I haven't gotten to play with iceberg tables or even Polaris Open Catalog, so I'm very intrigued and anxious to learn as well. So
All right, let's go for it.
great, go for it.
All right, for the audience, I'm Saurabh Kumar and I work as a senior manager in the data and AI team at Accenture Australia, where I help organizations design and build modern data platform at scale. I'm also honored to be a Snowflake data superhero and an AWS Golden Jacket, which has given me an opportunity to work closely with cloud and data communities across the globe. Outside of work, I co-host the Saurabh and Sagar Show, a podcast on YouTube and Spotify where we explore stories in tech, career, and human side behind the professionals we meet. I'm excited to bring those experiences in today's session as we dive into how Snowflake, Iceberg, and Polaris are reshaping the modern lakehouse.
Great.
So I hope you're ready because today we are diving in one of the most exciting shift happening in the data world right now. We have all heard the promise of the modern lake house, but the reality, multiple engines, multiple formats, duplicated data, broken pipelines, and the way too many late night Slack messages saying, why my table different in Spark and in Snowflake? Well, that era is ending because today I'm talking about building an interoperable data platform and how Snowflake, Apache Iceberg, and Polaris are redefining the model lakehouse. This isn't just an architecture pattern. This is the moment where open formats, open catalog, and governed access come together, finally giving us one data layer that any engine can work with reliably, consistently, and at scale. So let's jump in. So before we dived in, here's a quick look at what we are covering today. We'll start with a short introduction, setting the stage for why interoperability is becoming one of the biggest priorities in modern data platform. Then we'll explore interoperability challenges in data lake, what really happens when multiple engines like Spark, Flink, Trino, and Snowflake all try to access the same data. From there, we'll move into how Snowflake Open Catalog powers multi-engine interoperability. Next, I'll walk you through how this integration helps unify data lakes, connecting the dots between open formats, catalog, and Snowflake governance layer. Then we'll move into the demo architecture where I'll show how all these pieces come together in real world scenario, followed by a live demo. After that, I'll share a few best practices and recommendations, lessons learned from early adopters, and some design patterns to keep in mind. And finally, we'll wrap up with some Q&A. Imagine a world where your data isn't tracked by the tools you use, where Spark for big data processing, Flink for streaming, Trino for federated queries, and Snowflake for analytics and governance all work together seamlessly on the same data sets. No copies, no conflicts, no governance gaps. That's the world Snowflake is building with Apache Iceberg and Polaris, and it's closer than you might think. Now, before we dive into how Snowflake, Iceberg, and Polaris make this possible, it is important to understand why interoperability has been a challenge. Each engine, as you see in this diagram, Spark, Flink, Trino, Snowflake brings its own catalog, its own metadata layer, its own way of handling schema evolution and governance. The result, data silos, duplication, and a lot of late night troubleshooting. So let's start there by unpacking what makes interoperability so difficult in today's data ecosystem and why a shared catalog might be the missing piece. For years, organizations have been building powerful data platforms, each with their own preferred tools, engine, and storage choices. But underneath all that innovation, there is a persistent problem of catalog fragmentation. Every engine, whether it's Spark, Trino, or Snowflake, often comes with its own catalog implementation. Some uses an old Hive metastore, some rely on custom or vendor specific catalog. And the moment you do that, you create silos, pockets of data that can't be easily shared or discovered outside their native engine. So when teams try to combine workloads across engines, they end up duplicating data, re-ingesting it, or rebuilding metadata just to make systems talk to each other. Then there is a problem of atomicity and concurrency. Catalogs are responsible for coordinating metadata updates, things like schema changes, partition management, and version commits. But without a shared coordination layer, if two engines write to the same data set at the same time, you risk metadata conflicts or worse, corruption. Next comes governance and security. When you have multiple catalogs, each with its own way of defining metadata, you lose consistency. Policies like row level access, data masking, lineage tracking, or tagging might exist in one catalog, but they don't automatically carry over to another. That makes it nearly impossible to enforce a unified governance model across all your data engines. And finally, data movement overhead. Without a unified catalog, shared namespace, organizations resort to moving or copying data between systems just to make it accessible. Each copy adds cost, latency, and operational complexity. And ironically, the very act of moving data breaks the single source of promise of single source of truth. So let's look at how Snowflake Open Catalog powers multi-engine interoperability. But before I talk about the architecture of Snowflake Open Catalog, let's go back to the core challenge. Every data, every data engine speaks a different language. Spark, Flink, Trino, Snowflake, they all understand data, but they don't always agree on how to describe it, evolve it, or govern it. And that's exactly where things starts to break. Apache Iceberg was the first big step towards fixing that. It gave us a universal table format, one that defines how data is stored, versioned, and updated in object stores like S3, Azure Blob, or Google Cloud Storage. But here is the catch: even if everyone speaks the same language, they still need a common dictionary. That's where Apache Polaris and specifically Snowflake Open Catalog steps in. Polaris provides a vendor neutral REST based catalog service that acts as a single source of truth for table metadata, schema definitions, and transactions. As you see in this diagram, one REST API provides a unified interface between engines and the catalog, which point your data in the data lake. So when Sparks writes something, Trino and Snowflake immediately knows it's there. No duplication, no conflicts, no stale views. And then Snowflake takes this one step further. With Snowflake's open catalog and Snowflake Horizon, we get enterprise-grade governance on top of the open data ecosystem. Policies like data masking, lineage, and tagging extend seamlessly across all engines. In summary, Iceberg standardizes the table, Polaris unifies the catalog, and Snowflake ensures that it's all governed. So how does this combination of Snowflake, Iceberg, and Polaris actually unify data lakes? At its core, it's about creating a single source of truth. With Polaris as the shared catalog, multiple engine, Snowflake, Spark, Trino, Flink, all can coordinate over the same Iceberg tables. No more duplicate data sets or stale copies. Everyone sees the same version of truth. It also gives organization engine agility. Teams can choose the best engine for each workload, streaming, ML training, or analytics, without worrying about silos or data movement. Then there is governance and security. Through Snowflake Horizon, enterprise policies like row level security, masking, and lineage can apply uniformly across data accessed by any engine. That means openness without sacrificing control. Because Polaris is open source, it also breaks down vendor lock in. Your catalog layer stays portable and independent, even as your infrastructure evolves. And finally, it simplifies metadata management. Instead of building custom catalog or glue layers, Polaris provides a single production grade metadata service for all engines. So together, Snowflake, Iceberg, and Polaris deliver something we have been chasing for years: open, governed, and interoperable data, all built around one shared source of truth. Now we are about to see in action a demo of how Snowflake, Polaris, and Iceberg come together to form a truly interoperable data platform. In this demo architecture, we see data lake in Amazon S3 serve as a physical storage layer, holding the Iceberg tables, data file, and metadata. Snowflake and Apache Spark are the compute engine that both read from and write to Iceberg tables. Apache Polaris catalog maintains a namespace that organizes Iceberg tables and ensures consistent table versions, schema, and transactional across multiple engines. So the demo scenario looks like this. Snowflake creates Iceberg table through Polaris catalog under a given name. Snowflake then writes data into the Iceberg table. Spark then reads data from the same Iceberg table, maintaining ACID consistency. Now, this is one of the scenario. In this demo today, I'll go through 10 different scenarios. Now let's jump into the demo. Throughout the demo, I'll be transitioning across 4 screens. The first screen represents Spark running within a Jupyter notebook. The second screen represents a Snowflake account, which acts as another engine. The third screen represents a Snowflake Open Catalog account. And the fourth screen represents a data lake in Amazon S3. So the demo has too many moving parts. My intent of showing you all this screen is so that while I go through the demo and transition across the screen, it makes sense for you to when I'm talking about which platform. So if you look at in this demo, I have a data lake on Amazon S3, and I'm navigating through the bucket structure here, and I have a customer Iceberg table T1. Now I am in the Snowflake Open Catalog screen where I have a catalog called External Catalog Snowflake. This catalog is currently pointing to the data lake, which I've shown in S3 here. And we have some configuration around how the base location of S3, which the data catalog is pointing to. It's an external catalog, and we have some admin privileges that is granting access to the catalog. As I navigate through the connections, you have Snowflake and Spark as 2 engines which are talking to the catalog. And that's the principal role which is assigned to these 2 engines. Now, as I explore the catalog, I will see that we have Polaris demo Iceberg database, and then we have a schema and a customer Iceberg table, which we have seen in the. Now, this is my Snowflake screen where I'm showing the table, and we could see that Snowflake can query the Iceberg catalog. Now, this is my Spark screen where I'm able to see the Iceberg table while querying. So you see now we have this data lake on Amazon S3, and that can be referenced via the Polaris catalog. Then I have Snowflake and then Spark running on my local machine, which can query the Iceberg table. Now I'll go through running my first scenario where I'll go ahead and create a new Iceberg table called Customer Iceberg Table T2. Now Snowflake has successfully created the Iceberg table here. I'll go back to the data lake and refresh, and now see the Iceberg table T2 has been successfully created. I refresh the catalog and see the Polaris catalog can list the Iceberg table. I'll query Snowflake. Now I'll refresh and query my Spark engine and see the Spark can read the same table which was created by Snowflake. Now I go through the scenario 2 where I'll be inserting some records into the table. So this query has recorded 150,000 record into the Iceberg table. Let's go and query the table to see the content. You can see the Iceberg table which was created. Snowflake is able to query the table and display the content. We'll go to the Spark console and run the query and see if Spark can read the content of the Iceberg table. So see, Spark is able to read the content of the same Iceberg table which was created on Snowflake. Now we'll go through another scenario where we will be updating the Iceberg table with some record. So if you see, this query has updated 5 records into the database. Now let's go ahead and query Spark. So you could see we have 150,005 records. So Spark is able to detect the changes to the 5 record which was added to the table. Now we'll run another scenario where I'm inserting a custom record into the table. So that record is created. I'll go ahead and check the count. So we have one record inserted in the customer Iceberg table. When we query, we could see the customer table there in the table. Now this is the Spark console. We'll run the query and see if the new changes are there. So we could query the same customer key from Spark as well. So you're seeing across this scenario, the same table was created and updated across the two engine, and it has given a consistent visibility. Yeah, that's the end of my demo. I will move to the next screen. So let's talk about some best practices and recommendations. So when you begin your journey with Polaris and Iceberg, the key is to start small and scale with intent. Begin with a pilot workload, a single domain, or a few tables to validate interoperability, governance, and performance before touching mission critical data. Keep an eye on catalog health, monitor transaction latency, commit conflicts, and compaction metrics to ensure Polaris runs smoothly at scale. Then adopt schema discipline. Use Iceberg schema evolution and partition carefully to avoid unnecessary metadata complexity. Lead with governance alignment. Test your access control, filters, and lineage consistently across Snowflake, Spark, and other engines. And finally, stay close to the community. Polaris and Iceberg are evolving quickly, so track new releases, connectors, and best practices to stay ahead. Start small, observe carefully, and evolve deliberately. As we wrap up, I want to leave you with few reflections from past project and what they mean for you as you think about your own data platform. Across industries and use cases, I've seen the same pattern repeat. No matter how modern the stack looks on your diagram, platform starts to struggle where interoperability is an afterthought. Different team picks different engine, data gets copied just for now, catalog drifts, and suddenly you are maintaining a platform instead of innovating on it. One key takeaway for me has been that platforms rarely fail because of storage or compute. They fail because of fragmentation. Fragmented engines, fragmented metadata, fragmented governance. Another lesson is that open formats alone aren't enough. Adopting something like Iceberg is a huge step forward, but without a shared catalog and a unified governance layer, you are only solving part of the puzzle. And finally, the most important takeaway: interoperability isn't a nice to have feature, it's a design principle. The most successful organization I have been working with are the ones that intentionally designing for multiple engine access, consistent governance, and low friction collaboration from the beginning. With Snowflake, Apache, Iceberg, and Polaris, we are now have the building blocks to do this much more deliberate, robust way. My hope is that you leave today not just with the architecture pattern, but with a mindset designed for interoperability from day one. Thank you. Now we can go
Yeah,
through
I
some.
I have a lot. That was fantastic. And I have some questions, and
Yeah.
maybe the questions that people would want also. So, one thing you were showing at the beginning was all of, you got Flink, you got Spark, Snowflake, and then you have like the storage. All of those could possibly running on different public clouds. Do they all have to be running on the same public cloud for that level of an architecture to work? Or if, say, your storage is in Azure, but you're doing Snowflake on AWS, can that still be that architecture still be used?
Yes. So is the whole point is when we talk about interoperability, the whole point is you have your data lake in one cloud platform. You could still connect the Iceberg tables with engines running on any platform. So it doesn't have to be. But one point to note is when we talk about Snowflake Open Catalog or Polaris, there's a concept of external catalog and internal catalog. So
Yeah.
when you decide that that is a key decision an organization needs to take, whether they are using because with Iceberg there is an Iceberg native catalog which each engine has. Spark has
Yeah.
its native catalog for Iceberg. Snowflake has it, and if we decide to go ahead with a Snowflake native catalog, then what happens is there are some restrictions around read and write. So native catalog would allow you to write, but then other engines to read. In this
Yeah.
scenario, we are using an Apache or Polaris, which is an open catalog. In this scenario, you could see Snowflake can write to the table, but Spark can only read.
Right.
Now, if I turn the tables around and create an internal catalog, which is like an internal catalog in Polaris means all engines like Spark and Trino and Fling, they can write, but Snowflake can only read.
Right.
So
So
because this, as I said, this area is evolving. This is not like we are
right.
not haven't seen the North Star, but soon we'll have on an ecosystem where all engines can read and write without this limitation.
So you really need to have a good, like you said, when you were kind of like things to think about, really going in with the strategy in terms of like, is Snowflake doing a lot of the heavy lifting, but you just want to use Spark, whatever, to read the data, right, or the inverse, or
Yeah, yeah,
whatever, you know, it's really, one of my big things over the years was always about strategy. Stop, think about what you're gonna do before you go do it, so that you don't put yourself in a corner. Because that was one of my questions was, what if I've been using Iceberg prior to Snowflake supporting it for some time, and then now Snowflake comes, we want to put Snowflake, um, is that still possible to do, to sit there and say, now I'm going to put Snowflake on top of what we've already been using from Iceberg, and allow Snowflake to interact with that data?
yeah. So which means if you are already using Iceberg,
Yeah,
and which means you are not using a Snowflake managed Iceberg table,
right.
you are using externally managed Iceberg data. So you can
Yeah,
still, via this pattern, you can still have Snowflake talk to the Iceberg data lake,
yeah,
but not manage it. Like, which means as an organization, you are already managing the Iceberg catalog, and
yeah,
which which could some organizations tend to be flexible. They want to manage in-house rather than going proprietary Snowflake. But as I said, this is evolving, and soon, because interoperability isn't like it shouldn't be an afterthought. It should be like thought upfront when you are designing your data platform.
yeah,
So
exactly. I mean, this is amazing because I can remember, I'm only going to go back 5 years, where I had architectural, um, not really battles, but me and another architect, in terms of, Snowflake putting data in S3, they're writing Spark. And what was tough was that they had their needs, I had my needs, and we couldn't do anything except try to make two copies of the data, right? And it was, you know, are you primarily maintaining it, using it, and we just need to level your. So it was always this tug of war, like, where are you going to put it? And this is great to sit here and say, well, we can put it in a location we can both work with it and both benefit from. So that's pretty amazing.
yeah, yeah. And if you, for the audience, if you know that Snowflake has recently announced collaboration with other SaaS vendors, like we have in Workday and Salesforce, they
Yeah,
are also trying to adopt interoperability and make zero copy data sharing across the platforms
yeah,
via this Iceberg, which is great innovation. Imagine they don't have to copy data across
yeah,
platforms and share. Uh, so that's amazing to see how this um, ecosystem is evolving.
yeah,
I would also like to say that there is a generative AI wave, like it's a
yeah,
buzzword around, and every organization is talking about agentic AI. But I feel Iceberg and data interoperability is the foundations of our data platform.
yeah.
And
Have you seen, um, because I've heard organizations, hey, why not put everything in Iceberg and not in Snowflake? Have you seen like an impact in terms of performance, latency, capabilities that you can do in Snowflake that you don't have when inside Iceberg? Like, can you still do dynamic masking, or other things like that, that maybe you wouldn't want to put in an Iceberg if you really want to use these features inside Snowflake?
So if you look at it's a very good question, Keith. So if you look at the data in terms of there was a benchmarking done by Snowflake across query performances of native Snowflake native tables versus Iceberg table, which are managed by Snowflake and an external table. And you would be surprised to see there was negligible performance difference between the native table and Iceberg. And especially a lot of people were worried about what happens. The data is stored externally on object store in any of the cloud platform. And you have the Snowflake power of Snowflake virtual warehouses, compute engine querying. And you would be amazed to see that the performance difference was nearly negligible.
That's good.
And there's
Yeah.
a nice white paper on this, like comparing the query performance across and benchmarking. And with the innovation around compute, and now you have adaptive
Right.
virtual warehouses, and you're seeing this, uh,
Yeah.
this won't be a deal breaker in terms of performance.
Yeah. So that's good to know. No, that's
And
great.
your second question around data masking. So if you uh, data masking is more native to Snowflake.
Right.
So as we already see, when the data is stored, and as a user of Snowflake, when I log in, and masking gets activated based on my role,
Right.
like current role, right? So
Right.
if the Spark is querying my Iceberg table, Spark doesn't have that context of that role,
Right.
right? So
Right.
that restriction is still there. So only a Snowflake user within the Snowflake ecosystem
Right.
can do masking. In my demo, I did have the masking scenario where you could mask some comment columns and apply a masking policy on an Iceberg table, which is stored in the object store, and you still have your masking activated
Yep.
through Horizon Catalog.
Yep.
But while the reverse is not true, Spark has to then do an internal, then I feel there is one abstraction above these native tool where we call the universal catalog at Polaris catalog, where
Yeah.
you shift the role and access to your catalog level rather than native engine, which
Yeah.
means all engines go through the
Right.
same roles and permission and apply masking at catalog like level, not at native level. And that
Yep.
could solve the problem.
Yep. How about things like inside Snowflake zero copy cloning? Because I know when you do a zero copy clone, it doesn't physically copy the data. So does a zero copy clone still work on a an iceberg table?
So zero copy cloning was, as you see, the concept was your data is stored in micro partitions and on
Right.
Snowflake. And when you do a clone operation, it's a metadata operation.
Right.
So you have a copy of metadata which is pointing to your old micro partitions. Now, in for Iceberg, we don't have micro partition because data is stored on an external object store,
Right.
not within Snowflake.
Yep.
So I'm not sure if that would work, like if you copy and referencing, because you already have your Iceberg table lying outside of the Snowflake.
Exactly. Great. This was great. It was very informative, educational, and you know, I'm kind of a bit jealous that you get to play with it. My job on a daily basis, I don't get to, so I'm living vicariously through you, and what you've put together. But I think this was great because maybe this will kind of soften some of the battles of organizations battling across like multiple platforms and trying to move all their data to one specific platform. So
True, true. And then the biggest fear of organization around vendor lock-in, they
yeah,
at least don't have to worry about vendor lock-in because they are investing in an open format and open catalog. So
yeah, and data migration. I mean, it we're not moving megabytes or gigabytes of data anymore, right? It's terabytes upon terabytes, petabytes upon petabytes, and that's expensive to move around if you don't have to. That's even better. So, um, is there any way people can know more about you, more information on what you shared with us today?
yeah, I have a Medium page and a LinkedIn page. So if anyone wants to uh, connect with me, please connect with me on LinkedIn or follow my Medium page. I have published the content of the talk today into a Medium blog, so which is good if you want to do an offline read. So
Nice. And for everybody, we will also put the links to everything that Soro shared today right inside the comments below. Um, but again, I want to thank you for joining me today. This was a very exciting topic. I hope everybody enjoyed it. And again, thanks for coming.
thanks, Keith, for having me on the show. It was my pleasure, and I really enjoyed this conversation.
Great. Thanks, everybody. We'll see you all next episode. Bye.